But you got it. One advantage when you're tutoring somebody that's not taking a class is that you can go at whatever speed they need you to go at. Okay, if you can't make those out, let me know and I'll read them to you. The first one is 4 squared equals 16. Put that in log format. In other words, start by writing that. What's the rest of it?
Would you put a 2 before the log and then 4 afterwards?
No. 4 is the base. Remember one thing about logs. Here's the way you can always solve this problem. What are logs? There's one word that they are that you need to remember. Logs are exponents. They are the exponent. Okay? So that tells you immediately that you got to have a 2 over there because logs are the exponents. So the only thing you have to figure out is to where to put the 4 and where to put the 16.
Okay.
In other words, one of them goes right there, the base, and the other one goes right there. I'm sorry, what?
Would 4 be the base?
Yeah, so that goes in the little circle. What goes in the big circle?
16.
So that's how you make that conversion. Always. Remember, logs are exponents. Okay. Let's do this one. Give it to me in order. In other words, the next number you should be telling me is the base, and then the arguments, that's the big circle, and then the other side of the equation.
2 log base 2 9 equals 2.
We got to account for all 3 things. All 3 of those things need to end up being in our log expression. Where's the x go?
After the equal sign.
Right. In other words, we could have done this by knowing that logs are exponents, so the log expression has to equal x, and then we figure out that the 2 goes there and the 9 goes there. If you ever forget how to do it, just always remember logs are exponents, and that will answer it. So now let's go the reverse. Here we have the log expression, and I want you to give me the exponential form.
Okay. It would be 25 equals
Logs are what?
5 to the second power.
Right. In other words, if you remember logs are exponents, I know that the exponent has to be 2. Okay. do 8. Log base b of x equals y. What is the exponential expression?
Y equals b to the x power.
Okay, hold on. That's a b. Y is the exponent. Has to be, because logs are exponents. So whatever our exponential expression is going to be, y needs to be the exponent. Look at what you did on the previous one. It's the same exact problem. What was the answer to number 7?
25 equals 5 to the second power.
Okay, so use that same exact logic to put this one.
X equals b to the y power.
It's as simple as that. The way I remember it is when I'm going from log to exponential, I actually do it backwards. I do this to this power equals that. So I end up getting the same thing, I just reverse it. Just because that's the way I memorize it. Doesn't matter. You don't have to use my method for memorizing it at all. As long as you can get it. So, let me give you this. Write that logarithmically.
Okay.
In other words, I've given you the exponential, put it in its logarithmic form.
Log base y.
No. B is always this thing here. In other words, whenever you see a subscript and it comes from something that's got B in it, that's the B. B is always the base of whatever the exponent. In other words, wherever we find the exponent in the exponential expression, remember this is the exponential expression, so it's always going to have an exponent, but wherever we find it, whatever is below it is that. That's where that belongs. Okay, but I can make this easier. What has to be on the right side of the equation, of the log equation?
X.
Right, because logs are exponents. So now you only have to figure out where two things go, the b and the y. B always goes down there like that. In other words, you're never going to see a math problem like this. You know what I'm saying? B is always going to be the subscript. I shouldn't say always. You may get somebody that tries to trick you. You know, in other words, all three of these are variables, so they can go in whatever order I want. I actually could say y to the b equals x, and what would be the logarithmic expression of that?
It would be log.
Do the right side first, it'll probably be easier. It goes on the right.
Would it be x?
Logs are exponents. What's the exponent in that exponential expression?
It would be b.
Yeah. So b goes there. Now what goes in the little circle and what goes in the big circle?
Y goes for the base.
And the only thing left is that. So if you're having difficulty with these, just do the right side first, and then the rest of it will kind of solve itself. Okay? So there was one where I didn't put b as the base, and you're never going to see that, but at least you were able to handle it. The important thing is that no matter what letters I use, in other words, I could say p to the q equals r. What's the logarithmic expression of that?
It would be log, the equal sign would be q, and then base would be p, and the br.
Only thing left is r. So as long as you remember the base is always what's under the exponent, that's what's important. I think you got it. All right, let's go on. Oops. It says to evaluate that. Well, first of all, let's make sure we understand what we're looking at. What's the base in this expression?
10.
Okay, it's implied because there's none written. In other words, if you see log with no base written, it's implied that it's 10. So how am I going to figure out what this is? Well, first of all, let's let it equal something. Some unknown. Since we don't know what it is yet, we'll let it equal x. Just to make the problem a little easier. Now, let's stick the 10 in there to make it easier still. The way to evaluate this is to express it exponentially. Express this exponentially.
It would be
What's the base?
10.
So let's start there. What's the exponent of that base?
Pardon?
What's the exponent of that base? Logs are... If logs are exponents, what does the exponent of this base have to be?
X.
Yeah. That's what I say. When I do it, I take the number on the far left raised to the power of the number on the far right equals what's in the middle.
1/10.
Fine. So now we can solve this. We don't really need a calculator. We don't need logs. We don't need anything. 10 to what power is equal to 1/10?
-1.
Correct. So x equals -1. In other words, we solved a log expression. That I can replace with -1 if I wanted to. In other words, if you told me what is this worth, what is the value of that, I know that it's -1. Okay, let's do another one. Natural log of e. What's the base here?
10.
This is natural log, not log. This is ln. What is it?
E.
E, exactly. Okay. Now, again, they want us to evaluate it. So, based on our methods of evaluating it, I need to make it equal to some number that I don't know. So I'll say it's equal to x. And now the way to solve it, to solve for x, is to express it exponentially. Express it exponentially?
E to the x power equals e.
What is x?
1.
What? In other words, once you express them exponentially, the ones they're giving you are very easy to solve. They're not going to give you tough ones because you really would need a calculator to solve them. The only reason we've been able to solve both of these is because we could solve the exponential expression easily. I know that if e to the x equals e to the 1, then x has to equal 1. About this one.
You would set it equal to x, so exponentially it'd be 6 to the x power equals 216.
Okay, you're getting faster. That's good. What is x here? Take a guess. It's a small integer. In other words, it's never going to be something like 3.1. Otherwise, you wouldn't be able to do it. If x was anything but a small whole number, I would need a calculator to do it. It's only because what do you think it is?
3.
Right. X equals 3. And that's something you may or may not know. You may not know that 6 cubed is 216, but you can experiment with a couple of small numbers. It's never going to be 11 or anything like that because they wouldn't expect you to know that. Okay. The fact that you're getting faster means you've started memorizing it, and that's what we need you to do.
6 to the x power equals 20.
Okay. Can we figure this one out? 6 to the 1 power is 6. 6 squared is 36. So the answer has to be somewhere between 1 and 2, huh?
Mm-hmm.
Well, we don't know how to figure that out. In fact, I can't even figure that out on my calculator. There's no way. How do we figure that problem out? We go back to the log expression. In other words, on the calculator, we can figure that out. Since we can't figure it out without a calculator, how would I figure it out with a calculator? You only have 2 buttons on your calculator. What kind of calculator do you use, Isa?
A scientific calculator.
Is it a TI-84? Is it a Inspire? Do you know?
No.
All right. Not that important. Most calculators are going to have a log key and a natural log key. That's common log, base 10. That's natural log, base E. Well, we're dealing with base 6. My calculator doesn't have a log base 6 on it. So I have to remember what the change of base formula is. In order to be able to figure out that answer on my calculator, I've got to use the change of base formula. This is always equal to the log of a number on top divided by the log of a number on the bottom. Or like I say, like I like to think of it, it's the log of the big number divided by the log of the small number. And I don't mean 20 is larger than 6. I mean that's a bigger size number. In other words, I could make that 2. And now it's the log of 2 divided by the log of 6. You know what I'm saying?
Yeah.
Okay, and there's something else about the change of base formula. It doesn't matter. In other words, I can now get this from my calculator. I have a log key. I do log of 2. I divide it by the log of 6, and I'll have an answer. So if you're dealing with a base other than 10 or E, you have to use this change of base formula. Now, it just so happens that all of these log functions, the ratios are the same. In other words, the common log of 2 over the common log of 6 is the same as the natural log of 2 divided by the natural log of 6. It's also the same as the log base 17 of 2 divided by the log base 17 of 6. In other words, as long as the base is the same, all of those ratios are the same. That's 10, and that's 10. The thing is, we would never convert it to that because there's no reason to. I can't get that on a calculator. I don't have a log base 17 key. But I could use either that one or this one. Let me pull up my virtual calculator. Wabbit-emu. Do you have a calculator that's like this? We've been through this, haven't we?
Yeah, we have, but I don't have one yet.
Okay. Well, let me show you how to get this. If I wanted the log base, or the log of 2 divided by the log of 6, there's the log of 2. I'm going to need the right paren. There's the division sign. And then I want to hit the same one. I don't want to hit natural log underneath it. I want to make sure I do the log of 6 down there. And if I hit enter, it tells me that that number is 0.386852, so forth. In other words, it's another one of those irrational numbers that never repeats. Logs are like that. Kind of like square roots and radicals are like that. All right. Let's go to 13. Actually, I'm glad I found this page. This is excellent review material. This is everything that you really have to know. So how would I get, again, if I express this exponentially, what's it going to look like?
4 to the x power equals 7.
Can I solve that? In other words, the only time you can solve these without a calculator is if this is a whole number. Well, not totally. I guess if it was 4 to the x equals 2, I would know x is 1/2. So there are some others that I can solve that aren't whole numbers. But if it's over 1, the only way you can solve it without a calculator is if it's a whole number. Well, is this greater than 1? Is x
Yes.
greater than 2 or less than 2?
Less than.
So it's somewhere between 1 and 2, which means we can't solve it this way. We have to solve it this way. How do I do that on my calculator?
Log 7 divided by log 4.
This time I'm going to use, I guess I used that last time also. But just to show you, if I do log 7 divided by log 4, I get 1.4, and now I'm going to use natural log of 7 divided by natural log of 4, you get the same exact number. So the ratios are the same whether you're using log base 10 or natural log. In other words, whenever you have to use one of these change of base formulas, doesn't matter which one you use. You can use common log or natural log. Okay, condensing and expanding. First of all, let's review some of our rules. The log of A times B is equal to what? We're going to have three things. We're going to have the log of A times B, we're going to have the log of A divided by B, and we're going to have the log of A to the b power. Each one of these expands into something a little more useful for us.
Log A plus log B.
That's that one.
Log A minus log B.
That's that one.
And B log A.
That's that one. Good. Very good. So now we're ready to answer these questions. Condense. Condense just means go the other way. Okay. This is a little tricky, but as long as you have it memorized, what would 4 log s condense to? What's the first step of condensing that?
Log s to the 4th power multiplied by log y to the 3rd.
Well, first of all, let's do it step by step. So that's the first step. Those two expressions are the same. Now, the next thing is I want to turn it into a single log statement, not 2 log statements.
Log s to the 4th, y to the 3rd.
Exactly. Okay, let's look at another one. And incidentally, these expanding and condensing can only be done if you have the same base. In other words, if this was log base 2 and this was log base 3, I couldn't do it. So this, which one can we do step 1 on first?
The second one.
Okay, so I got log base 2 of 10 minus what?
Log square root of 4, so technically 2.
Beautiful. And now what? Single log statement.
And then 10 divided by 2, so 5.
Good. Hold on. Some of these are, okay. That was condensing, those two. This is expanding, merely going the other way. Excuse me, hold on. 1 second. Sorry. Okay. So we're going to go, in this case, we're going to start with one expression and expand it into 2, 3, 4, who knows how many. Let's do it one step at a time. And they're all going to be base B's. So what's the first one?
Log base b 5x squared minus log base b z cubed.
Next expansion. That can be more expanded more. So can this. Both of them can be.
2 log base b 5x minus 3 log base bz.
And technically, it can actually be expanded one more time because I got multiplication going on right there.
Oh. 2 log base b 5 plus 2 log base bx.
Minus 3 log base b of c. So I did end up with 3. And the only advantage in doing this is that that's a number. I can get that out of any calculator. I mean, assuming I know what the base is. Okay, so I might do that. In other words, I might want to expand that 5x into 2 separate things. Because one, the variable I'm not going to be able to do anything with. But I can simplify that quite a bit. That's a number. And this, so as a first step, let's get rid of the radical sign. That's always a good thing to get rid of whenever you're dealing with logs. So how would I write that? Instead of square root of x, x to what?
To 1/5.
1/2. In other words, that's always the root when you have a fractional exponent. If I said x to the 1/3, that would be the cube root of x, like that. If I said x to the 1/5, that would be the 5th root of x. So when we have the square root sign, that's always going to convert to the exponent 1/2. Now, expand it. You can do it step by step or just give me the final long-term answer.
Half log base 2 5 plus
Okay,
half.
hold on one moment. That half does not apply to the 5. Notice that there are not parentheses there like that. And the 5 was not inside the radical sign. So the half doesn't go with the 5. It only goes with the x. In other words, if we do it in 2 steps, this is the first step I would do. With me?
Yeah.
Now the second step would be to bring that down. But I don't end up with a half in front of this first part. I do over here. So that's fully expanded, and that is definitely just a number. We could pull that out of the calculator. Not that you ever do. Logs are a little bit like radical signs. You don't want to put a decimal approximation for that. You want to make it a precise exact number, and what that number is log base 2 of 5. So it's a number, and it's important that you always realize that that's a number, as opposed to this is not a number because there's a variable over there, x. Okay? But there's no variables left here. So that's a number. But recognizing that the half goes with the x and not with the 5 is important. Let's go back and look at this slightly different. Let's put parentheses. In other words, let's put that 5 under the radical, so it'd be the square root of 5x. Then I would write it like this, right? And now the half would apply to both of them. So I would have a half in front of there, and then of course this becomes a half in front of there, log base 2 of x. So it really depends on what the exponent is applying to. Remember, exponents only apply to what's below them. If I write this, that cubed applies to the x only. It doesn't apply to the 2, doesn't apply to the minus sign. Completely different. Now the 3 applies to both the 2 and the x. Completely different still. Now the 3 applies to the minus sign, the 2, and the x. Ooh, blurry. It's okay. You can still figure it out. Solving equations. They have to start us out with such a tough one. All right. When you're this is an exponential equation. Why? Because our variable x, remember e is a number, e is not a variable, but our variable is in the exponent. Typically, we don't have an algebraic way of solving these. In other words, if I said 2 to x is equal to 9, there's no algebraic way of solving that. You have to convert it to logs and then use your calculator to solve it. Okay, so anytime you see an exponential equation, and that's defined as having the variable in the exponent, your goal is to try to isolate that for starters. Then we'll switch it and maybe logs will work for solving it. Usually, to solve exponential equations, you have to take logs. In other words, let's hold off on this for 1 second. And how would we solve this problem right here? Write the logarithmic expression of 2 to the x equals 9.
Log base 2 9 equals x.
Correct. So we can solve it because I can get that number out of my calculator. That would be the log of 9 divided by the log of 2. So that's a number, and that's what we were trying to solve for. So when we have an exponential expression that we can't solve, we have to use logarithms to solve it. So we're planning on using logs to solve this thing. But first of all, we have to get that isolated. What's the first step?
Subtract 23 from both sides.
If we're trying to isolate this, we want to get everything else on the other side of the equation.
Then add 17 to both sides.
Now what?
Divide both sides by 5.
Now what?
Take the natural log of all sides, both sides.
Very good. Now what?
The natural log and the e on the left side would cancel out. So 12.
Okay, in other words, yeah, the reason it cancels out is because if I bring that exponent down in front, it becomes this, and the natural log of e is 1. So you're right, it doesn't really cancel out, but it becomes 1. And so 12x is equal to the natural log of 8. So x is equal to?
Natural log of 8 divided by 12.
Again, that's your answer. In other words, again, you don't want to put down the decimal answer. You want to leave it exactly this way. Natural log of 8 divided by 12. Okay. First step.
Subtract 1 from both sides. Divide both sides by 2. Make the natural log of both sides, so x equals natural log 2.
Good. What's x equal here?
X equals natural log 12.
Good. Okay. First step.
Take the natural log, or take the log of both sides?
You know, you can take either, but when I'm solving exponential equations, I generally stick with one or the other just so I don't get confused. I love natural log, and I'll tell you why. Is when you get to pre-calc and calc, everything is natural log. In other words, a year from now, you would not have said common log, you would have said natural log, just because the natural log is the most valuable log for calculus. It's hard to explain why. I don't really need to, but you could take the common log of both sides, but natural log works probably a little bit better. And what's the next line? In other words, that no longer equals 1, so we can't solve it the way we solved the last problem. But what can we do here? What can I do with this exponent?
Could you do x plus 5 natural log 2?
Yeah. In other words, that third rule regarding logs allows me to bring any exponent, no matter how complicated, down in front like that. Now what?
Divide both sides by natural log 2.
And now what?
Subtract 5 from both sides.
And that is my answer. Expressed exactly like that. And in case you're wondering, can I do anything with this?
You can put it into a calculator.
No, that's the tricky part. And that's why I asked, because I didn't want you to confuse that. That is not the natural log of 8. Notice that the natural log of 16 minus the natural log of 2 would be the natural log of 8. In other words, I could expand, I can't expand this expression because I'm dealing with division of two log expressions. The division property that we are used to dealing with is where the division takes place only in the argument. And then log of a over b converts to natural log of a minus natural log of b. But notice that there's no natural log of anything divided by natural log of anything. So it's tempting to try to apply the rules of compression or expansion to those kind of things, but they don't apply. Just remember, this rule here does not apply to that expression in any way, shape, or form. So I can't reduce that, really. That's the final answer. There's no way to reduce it. Okay. No, you're doing good on these. I think you're getting it finally. Don't you?
Yeah.
Now let's just play with a different approach here. Normally I say I would take the natural log of both sides. Let's go ahead and do that. Now what?
X natural log 2 equals natural log 12.
So x ends up being equal to natural log 12 divided by natural log of 2, right? Well, a lot of people would prefer to do this a different way, and that is they're going to take the log base 2 of both sides. The reason being is that that is equal to 1. So if I take the log base 2 of both sides, I get the answer in one step. But notice I can't give that as an answer because it's not, I cannot get that number out of the calculator. So I still need a second step, which is to use the change of base formula. So that becomes what?
Log 12 over log 2.
Which is exactly what we got when we took the natural log of both sides. And we got it in 2 steps. So there's no real advantage in taking the log base 2 of the left side. And so whenever you're solving any exponential equation, perhaps if there's an e involved, then you always want to use natural log for sure. But even if there's any other base, it doesn't matter. You still use natural log. I'm just going to advise you to use always natural log when you're solving an exponential expression. If you had a teacher, they might even tell you to take the log base 2, but I don't like it because it doesn't work on the harder problems. It only works on the easy ones. Whereas if you take the natural log of both sides, that works on all of it. Now, was that page 1 or was that page 2? Let's see, we only have 3 minutes here. Your mom wants me to give you some homework. All honesty, I've never been asked to do that since I've been a tutor for 7 years. And that's because most of my students are taking a class and they already have a teacher giving them homework, and I'm usually there to help with the homework. So, but I'm certainly willing to do what your mom requests. Do you want me to, and the homework I'm going to give you, I just found a couple of pages, and I'll just send them. They're more log questions, more expanding, more approximating, more evaluating. Okay?
All right.
And in fact, it's got one there that we just did, log of 1/10. So it'll be worth it for you to do these. I suspect you kind of have it down now, but if you don't, doing 1 page of these, you will by the time you're done this 1 page. So I'm going to send this 1 page to you. And the only question is should I send it to your mom's email address?
No, you can send it to mine.
What is yours?
I can text it to you.
Okay. Open text it. Can you put it in the chat room here? If you go over to the go to meeting.
Yeah.
And the way you type something into that chat room is you type it where it says type message here, and then you hit enter, and it goes into the chat room. There you go. And then I copy it. That it?
Yep.
I will email you this 1 page of homework.
Right.
And yeah, it shouldn't be too tough for you to complete that page at all. I think you'll have an easy time of it. All right, Isa, I will talk to you next Friday.
All right.
Bye-bye.
Bye.